Good morning, dear student. I am Tarungar. Today we will discuss about the bonding in solids, which is important to differentiate different in the different types of bonding in the material. So, what is bonding in solid? Basically, we know each materials or substance form of number of atoms or molecules. Number of atoms and molecules, the nuclei range, atomic range, atomic or intermolecular separation or distance is range of 10 raised to power minus 10 meter, and one atomic substance or atomic material which have 10 raised to power minus 22 and 20 approx 23 atoms are present in regular periodic manner. It means regular periodic manners of these atoms are arranged in three-dimensional space. In atomic substance, 10 raised to power minus 23 atoms per gram present. So, the atoms composed of positive nuclei surrounded by electrons. So, all atoms are separated by equal separation. So, in atoms, we have seen nature of the force between all the atoms, which is long ranges as well as short range. So, how to define the long ranges and short ranges forces in the material or the matter or the substance? So, let us consider the nature of the force between atomic substance. Let us consider this is the A and B atoms separated by R separation. So without considering force acting between these atoms, the potential energy written as minus alpha raised to power L plus beta raised to power R2 to power N. This potential energy denote the nature of the atoms. This is the graphically we have seen. When separation R is increased, the nature of the force, this is the repulsive due to the second part B upon R raised to power N, and this is attractive nature. this curved line shows the nature of the attractive force between the two atoms, or these atoms. So now we have seen at equilibrium position. At equilibrium position, what is the attractive and repulsive force? The equilibrium position is R equals to R naught. First we have seen the force between these two atoms, which is the negative gradient of the potential energy. The negative gradient of potential energy, which is known as force between these two atoms. So sometimes this is considered a equation A. The equation 1 A differentiate with respect to R, we have getting minus alpha n power alpha n plus 1, also beta m upon r raised to power n plus 1. This is force between these atoms. At equilibrium position, and we have also seen the nature of the force between two atoms by this equation. We have seen this nature is, this line shows the nature of the repulsive when R is increases, and this line shows the nature of attractive force among these atoms. So when we have seen at equilibrium position, this line shows the total force between these atoms. At equilibrium position, the R equals to R naught, the total force between these atoms will be 0. But total energy between these atoms is U बराबर this times this, so U बराबर minus U mean, or also written is U naught. 8 R equals to R naught. So we have seen in this both graphs the force at equilibrium position when R is R naught, force tends to 0, but this potential energy is not equals to 0. This potential energy is minimum energy. And what is the minimum energy? Minimum energy is the dissociation energy or the binding energy, which is separate to these atoms are isolate. So U mean is known as the dissociation energy or binding energy of molecules to separate. Now we have seen the minimum potential energy U mean or U naught when R बराबर or not. So we have seen this U minimum energy is R बराबर R naught minus अल्फा n R की पावर R बराबर R naught n plus 1 plus बीटा m R naught m plus 1. When we solving, so we have get u mean बराबर minus alpha r raised to power n 1 minus n by l. This is the condition of the minimum or dissociation energy. This equation shows the binding energy or dissociation energy which is separate the atoms in the molecules. Now we have differentiate U minimum again. So U minimum is minus alpha n r naught raised to power n plus 1 and beta n r naught n plus 1. So again we have differentiate this equation when this is positive. Minimum energy when d2r d2u upon d2r is positive. It means this d by dr minus alpha n r naught raised to power n plus 1 plus beta n r naught power n plus 1. So sometimes we consider r naught equals to only r. So this is the r. So again we differentiate with respect to r. We have getting n plus 1 alpha upon r to the power n plus 2 plus beta n plus 1 m upon r to the power n plus 2. So this equation equals to 0. So we have putting equals to 0. So we have getting also here we have seen value of n by n. So finally we have seen when it equals to so m plus 1 is always greater than n plus 1, which is so m is always greater than n. M is always greater than m. It means that the minimum potential energy is the U बराबर U naught. So this is our this overall derivations shows the minimum potential energy is depend on the M and N. M and N are constant. Alpha beta is also constant. R is the separation between two atoms. So overall, this derivation is to need to differentiate between different types of bonding in the material, which is known as before define types of bonding. We have known that atom is made of a crystal is made of number of atoms, and in every crystal have different properties due to their outermost electron. We also say free electrons. So every crystal number of free electron is different due to their valence electron different. The nature of the crystal or bonding is different, and due to them their physical, electrical and mechanical and magnetic property are different. So we have, on the basis of the outermost orbit electron in periodic table, 5 types of bondings and bonding forces. One is ionic bonding, second known as covalent bonding, third known is metallic bonding, fourth name is van der Waal bonding, and fifth known is hydrogen bonding. These all types of bonding is differentiate due to their valence electron in the material or atom. So this remaining part we will see in next lecture. Thank you so much.